Hello everyone, this is Shekhanya of Sri Venkateswara College of Engineering, pursuing my sixth semester in CSC branch. So today we'll be covering topic the introduction to thermal energy storage system of renewable systems. Moving forward, as we all know that thermal energy storage systems, also known as TES systems, are technologies that store thermal energy for later use. They can store energy in the form of hot or cold or heating, cooling, or power generation, and that can be later used. Moving forward, what is the importance of thermal energy, why we need to store, and why it is very important? First is grid stability, cost saving, and energy efficiency. So moving more into the topic, TS in stability, TS helps balance electricity system and demand, supporting the integration renewable energy sources. Energy efficiency. TES helps to efficiently of heating and cooling systems by shifting energy use to off-peak hours. And cost saving. TES reduces energy cost by allowing user to use minimally advantage of lower usability rates in during power offsets. So these are some of the importance. Moving forward, and their basic different types of thermal energy systems that are sensible heating storage, latent heat storage, thermochemical energy storage system. So what is sensible heat storage? Storages heats by increasing the temperature of solid or liquid medium. So these are the sensible heat storage. Latent heat storage stores heat through the phase change of materials such as melting and freezing. The next is the thermochemical energy storage. This storage heat stores heat through reversible chemical reactions or sorption process. These are the three different types of thermal energy storage. Next is moving forward to more to know what is sensible heat storage and how it works. So how does sensible heat storage work? So sensible heat storage raises or lowers the temperature of a storage medium such as water, rock or soil. And common medium are water, rock, sand and concrete are commonly used in sensible heat storage media. Applications of sensible heat storage system are used for space heating, water heating, and industrial processes. So these are some of the sensible heat storage. As you can see in the figure, there is a cycle, or the figure shows how sensible heat storage works, where where the cold air comes from the home in return, and there's a hot air loading in the home, and the cycle follows. There are two cycles: charging loop and discharging loop. So charging loop where solar collector, fan, and there is also a packed bed drop tank in which the energy is being stored. So this is a process, basically cycle, in which the process takes place. Next is the latent heat storage. So phase change. So latent heat storage works by utilizing the phase change of a material such as melting and solidification of salt or wax. Next is energy storage. During the phase change, a large amount of energy is absorbed or released at a constant temperature. Next is what is the efficiency of latent heat storage. Latent heat storage can achieve higher energy density and efficiency compared to sensible heat storage. So basically it is more preferred than sensible. So you can say that sensible is beneficial, but latent is more beneficial than that. So here in this also they have given a proper life cycle of how the latent heat storage systems takes place. There's a solar thermal conductor, latent heat thermal energy storage unit. Then there's a thermal loading loop where there is a cooling water loop and chill water loop. So these are the cycles in which the absorption or the storage of heat takes place. Next is the thermochemical energy storage. So reactions. Thermochemical storage utilizes reversible chemical reactions to store and release energy. So basically, chemical reaction is being processed in the whole cycle through which the energy is being received and being stored. Next is sorption process. It can also store energy through absorption and desorption of gases or porous materials. Next is high energy density. Thermochemical storage can achieve a very high energy density, making the term more storage and making having more thermal energy storage. In this, as you can see in the figure, there is a proper cycle taking place with how the concentrated solar energy, and then thermochemical storage system. So proper cycle is being performed for thermochemical energy storage with proper reactions, and which energy is being received at what time and how is it being utilized. And so some of the applications of thermal energy storage are building HVAC. So TCS systems can be integrated with heating, ventilation, and air conditions called as HVAC systems to store thermal energy for later use. Next is industrial processes. TES is used in industrial settings to store waste heat or to meet process heating and cooling demands. Next is renewable energy integration, which is the main point. So TCS helps integrate intermediate renewable energy source like solar and wind by storing excess energy for later use. So these are some of the applications. There are more application of thermal energy, but these are basic application which people use in real life. There can be more certain high complex level application, and these applications are just the basic terms which we use in real life. And so moving ahead, what are the benefits of thermal energy storage system? As so improved efficiency, reduced emission, and cost saving. Thermal energy is a bit complicated, but it has also some benefits. That is, it can help improve the efficiency of heating and cooling systems by shifting energy used to off-period peaks. By supporting renewable energy integration, TCS can help reduce greenhouse gas emission and environment impact. TCS can also lower energy costs by taking advantage and then utilizing rates and reducing the need for the exchange and the capacity. So these are some basic thermal energy storage, and we all know that if there is benefits, there may also be some limitations of certain energy. So these are just the benefits which we are looking forward. And as we know that benefits also might have challenges and limitations. So the challenges and limitations are high cost. The upfront capital cost of TCS systems can be bear to widespread adoption. Technical limitations. Certain TCS technologies may have limitations in energy density, power output, and storage duration. Integration complexities. Integrating TES with existing energy systems can be technically and logically challenging. So some of the challenges we have in this PPT, I haven't mentioned more of the challenges, but these are the basic challenges which people face or we face in general while using the thermal energies. So heat storage in graphite thermal storage media. So these are the future trends which can be adopted in thermal energy, that is advanced materials, hybrid systems, and digitalization. Ongoing research is focused on developing new materials with improved thermal properties and energy densities. Hybrid systems, so combining different TES technologies can create more versatile and efficient energy storage solution. Digitalization, the integration of IoT, AI, and smart control can help in better performance and improvement of TCS system. So we can also know that future trends of particular storage or energy, and not just now, in future there'll be more development and we can also have more future trends. These are just a few which has been uh, displayed here. So hope you like the PPT and hope you understand. Thank you.